Flipped Classroom video for Maths AS Unit 1, Solving Triangles. We're going to have a look at using the sine rule first. So we have a triangle XYZ such that one side is 32 centimeters, another is 15, and a particular angle is 19 degrees. And they've asked us to find the possible values of the angle at x to the nearest degree. So the first thing we're going to do is to sketch what we've got into a diagram, look at the information, and that will tell us how to proceed. So there's our line XY, which is 32 centimeters, and the line XZ is 15 centimeters, and the angle at Y is 19 degrees. So if we put a dotted line to show where that line YZ is going to be, we can see that we can put a line from X to that line that way. So Z is then where you can see it, but we could also put it that way. And so that's why it's saying find the possible values of the angle, because there's more than one. So what can we do with this triangle? Well, we can use the side of length 15, whichever position it is in is opposite to the 19 degree angle. And so we can use the sine rule, because that involves sine A over A, for example, which is the sine of an angle divided by the length of the side opposite to it. Now, the other side we've got is 32, and that is opposite the angle at Z. So we're going to use sine of XZY, meaning the angle at Z, divided by 32 is sine 19 over 15. And we can rearrange that by multiplying by 32. So we have that the sine of the angle at Z is equal to 32 sine 19 over 15. And we can pop that in the calculator, and that gives us 0.694. And the dot 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 there means lots of decimals. And we can then do sine to the minus 1 of that to find out what the angle at Z is. So what the calculator tells us is that the angle at Z is 44 degrees. And looking at our diagram, that's going to be the angle at the red Z, because that one is less than 90. The angle at the green Z is more than 90. And that gives us a clue as to where the other angle is. So what we can do is we can think about what the sine curve looks like, and it looks like that between 0 and 180, and we've marked across with a dotted line where 0.694 comes on the y-axis, or the sine of the angle axis. So where it first hits the curve is our 44 that the calculator gives us, but it also hits again at 180 minus 44, and it's 180 minus 44 because that's symmetrical. So the distance along from 180 back to that point is going to be 44, hence 180 take away 44. So that gives us the other angle being 136, and the 44 is in red just to indicate that that is the one at the red Z. Okay, so now we know the angle at Z, but of course we've been asked for the angle at X. But if we've got two angles in a triangle, we can work out the third quite easily. So YXZ is either 180 take away 44 plus 19, which are the other two angles in one of these cases, or 180 minus 136 plus 19, which is the other case. And that gives us 117 or 25. And we can see the 117 is the angle there, corresponding to the 44, the red 44 angle, and the 25 degree angle is there, with the green line going to the green Z. And this situation where we can't be sure, given the information in the question, which triangle it ends up as, is called the ambiguous case. Okay, now in this question we're going to use the sine rule and the area of a triangle. And this is the same question up to a point, so we've still got the same triangle, and the extra information we're given is that the area of XYZ is 200 centimeters squared to one significant figure. Now, the point of the extra bit of information is that that then means we can eliminate one of the possible triangles. And that's why the question says find the value of yxz to the nearest degree this time. So, we would do what we did before, and that ended up with having yxz being 117 or 25. But then we can use this information we have about the area to distinguish which one is the correct one. So we're going to use the formula for the area of a triangle, which is a half AB sine C. And we could at this point do a half XY sine Z, and that might be easier, and it's up to you to decide which way you want to do those sort of things. In this case, I'm going to put A and B on the diagram, and then C for the angle between them, which is the way that it's laid out. Of course, always the little letter is opposite the angle, which is represented by the big letter. So side little c would be the side from Y to Z. But we don't need that for now in this question anyway. So let's see what the areas are. The area of XYZ, if the angle C is 25, is a half times 32 times 15 times sine 25. And we pop that in the calculator and we get 101. That's to the nearest whole number. The area of the triangle when the angle at C is 117 is a half times 32 times 15 sine 117. And that comes out at 214. And that is the one that is 200 to one significant figure, which we could have deduced actually from the previous calculation, but it's good to show all your working anyway. And so we can conclude from that that the angle at X must be the 117 degrees. Okay, now we're going to have a look at a question that involves the cosine rule, and we again are given a triangle with some of the information, and we need to find the length of the other side. So, what do we know? Well, we can sketch this situation. Essentially, it doesn't really matter that much how accurate your triangle looks, although it's worth getting it there or thereabouts, because then when you get your answer you can see whether it's sensible or not. So in this case I haven't done it terribly well, but it's a sketch, and notice that the angle at the top there, if I work out cos to the minus 1 of 2/5, so this is the angle at P, that comes in at about 66 degrees, and that angle on that triangle I've sketched is there or thereabouts. The length 5 should have been a bit shorter really, but we're still going to know roughly if we're in the right ballpark when we get our answer. Anyway, find the length PR. Well, we want to label that angle accurately, and in fact I've put cos to the minus 1 2/5 for that angle. We won't have to bother with working it out in fact, because this is the cosine rule, so we're going to use the 2/5 itself, but it's good to label things so it's all clear. So here's the cosine rule. A squared is b squared plus c squared minus 2bc cos A, and again I could have done this as p squared equals q squared plus r squared and so on, but again it's up to you if you want to choose to do that. Most people stick with the a, b and c because then it's familiar and less risk of making a slip, but it's fine if you want to change the letters around as well. So what I am going to do is make life clear for myself by labelling the triangle again. So the angle is going to be, the angle we know about is A, because that's the version of the cosine rule I've written down, and then the other sides follow. And we can see then that the side we're trying to find, which is PR, is in fact little b. Okay, we've got various values we can plug into that. So we have 11 squared equals b squared plus 5 squared, which is c, minus 2 times b times 5 times cos A being 2/5. And you can see we've got a b squared there and a b. So what's going to happen? Yep, you're right. I heard you screaming at the screen. It's going to be a quadratic. Well, we need to tidy up, so let's see what happens. 11 squared is 121, b squared is still b squared, 5 squared is 25, and then if we multiply 2 by 5 by 2/5, the 5's cancel, we're left with 2 times 2, so that's minus 4b at the end. So now if we put the 121 on the other side by subtraction, we're left with b squared minus the 4b minus 96, which is of course 25, take away 121, and that will equal 0. So as you will already know, we need to put the quadratic equal to 0 to solve it. And now we're looking for numbers that multiply to minus 96 and add to minus 4. And there's lots of ways to do this. One way is to write a table of all the possibilities. We know we're multiplying to minus 96, so we write the pairs that give us minus 96. We know that it adds to minus 4, so it must be the bigger number that's negative. So we can see that 8 and minus 12 fit the bill. So that means we've got b minus 12 times b plus 8 equals 0. And that means b is 12 or minus 8. And we know that b is greater than 0 because this triangle, this is just the length of a side. And that means b must be 12. And that means PR is 12. And it's not essential to write that, but they have asked for the length PR, so just because we've relabeled it as B, we ought to just make clear that it is PR equals 12. And then just because I can't help it, I've put it on the triangle itself. But not just because I can't help it, because I want to see if it's a sensible answer, and even given that it's not really quite to scale, my sketch, it's certainly in the right sort of ballpark. We can be happy that we haven't completely got it wrong. So that's the cosine rule, the area of a triangle, and the sine rule.